In the previous lesson, we talked about sequences in general. Today, we're going to focus on a particular kind of sequence that comes up quite often in dealing with real-world problems, which we'll look at a later date. Today, we're going to talk about arithmetic sequences. An arithmetic sequence is one in which the values of the terms increases or decreases by a constant value. That means I'm adding or subtracting the same thing each time. So what I do is I look for the difference in the terms, and that value then is called the common difference, and we abbreviate it as D. In the sequence 5, 7, 9, 11, U sub 1 is 5, and D is equal to 2. So I could write a recursive formula easy here. U sub n plus 1 is equal to U sub n plus 2. U sub n plus 1 is equal to U sub n plus D for any of them, for any arithmetic sequence. But really, that doesn't help much if I'm looking for the 100th term or the 30th term, where I have to add 2 every single time. So it's much better if I can come up with me a general formula here, or a deductive formula. So let's see if we can find this pattern to find that nth term. We know that U sub 1 is the first term. So if I want the second term, I'm going to take the first term and add D to it. If I want the third term, I'm going to take the second term and add D. But I know that the second term is the first term plus D. So really what I'm doing for that third term is I'm taking the first term and adding D twice in order to get to the third term. So that's going to be the first term plus 2D. For my fourth term, I'm going to take the third term plus D. But the third term is the first term plus 2D, and now I'm adding another D, so I'm going to get the first term plus 3D for the fourth term. So let's look at that pattern. Let's try to figure out that pattern. My fifth term is the fourth plus D, but the fourth was U plus 3D. When I add another D, I get U1 plus 4D. So we're seeing it's the first term plus 4D for the fifth term, first term plus 3D for the fourth term. I think I see it. We could keep going on, but what we end up with is that U to the n is the first term plus n minus 1 times D. So if I'm looking for the 10th term, n minus 1 is going to be 9D. If I'm looking for the 20th term, 20 minus 1 is going to be 19D. So I can get that same thing each time. So let's look at some examples. Find an expression for the nth term. Well, we just said that the nth term is the first term plus whatever n is minus 1 multiplied times the common difference. So in this case, my first term is 18 times n minus 1. My common difference to go from 18 to 15 is to go down 3. And notice it goes down 3 every single time, so D is a negative 3. So if I work this out then, I've got 18 minus 3n plus 3. So U to the n is, not 18, 21 minus 3n. 18 plus 3 gives me my 21. So now I have a formula for the nth term. So if it wants me to find the 15th term, so U sub 15, or the 15th term, is 21 minus 3 times 15. So in this case, U to the 15th, or U sub 15, is 21 minus 45. So the 15th term is a negative 24 in this case. What other type of problem might we encounter? Here's a finite series, 3, 5, 7, and so on up until you get to 37. It wants to know how many terms are in that sequence. Well, we're still going to do this same thing. We're going to say U sub n, where n is how many terms it takes to get to 37, and U sub 1 plus n minus 1 times D. Now we know that the last term is going to be 37. We know the first term is 3. What we don't know is how many terms it is, so n minus 1. And we can look at this and see we're going up 2 each time, so D is 2. So if 37 is equal to 3 plus, simplifying this, gives me 2n minus 2. and so 37 is equal to 1 plus 2n. Subtracting 1 gives me 36, and so 18 is equal to n. So we know that there are 18 terms. Now if I wanted to check that to make sure, u sub 18 would need to be equal to 3 plus 17 times 2. Is that true? 3 plus 34 is 37, so yes, the 18th term is 37. So we know that's the 18th term. Now it gives me a sequence, but it doesn't tell me u sub 1, it tells me u sub 10, and then u sub 14. So I know the 10th term and the 14th term, and it wants me to find the common difference. Well, if I think back about how we did this, what I can remember is if I take u sub 14, I'm starting with u sub 10, and how many times am I adding d? Well, to get from 10 to 14, I'm adding d 4 times. So that means that 79 is going to be 55 plus 4d. So when I subtract 55, 24 is 4d, so d is 6. So I know that the common difference in here has to be 6. If I start at 55 and add 6 4 times, I should get up to be 79. What was the first term of the sequence? Well, let's see if we can figure that one out. We know that the 14th term is 79. We don't know, that's equal, not plus. We don't know the first term, but we do know that for the 14th term, I've got to do 13 n minus 1 times d, which was 6. So 79 is u sub 1 plus 16 times 13 is 78. When I subtract 78, 1 is u sub 1. So I know that the first term is 1. If I wanted to check it, I'd go back and use this 10th term equal 55 to make sure. Is 55 equal to 1 plus that's the 10th term, I need 9 times 6. So 55 is equal to 1 plus 54. That is true. So I know that 1 must be that first term. So that would be accurate. Now here's some for you to try. I want you, when I put up the problem, I want you to pause the video, work this problem, and then check your answer to see if you got the same thing I did. Write a formula for the nth term of the sequence and then find the 30th term. So u sub n is u sub 1, 7, plus n minus 1 times the common difference. In this case, that is going up 3 each time, so that's 3. So that is 7 plus, multiplying this out gives me 3n minus 3. So that is 3n plus 4. So I could write that as 4 plus 3n. Doesn't matter which way. Now for the 30th term, u sub 30, then using this formula is going to be 3 times 30 plus 4. 3 times 30 is 90 plus 4 is 94. So the 30th term is 94. That worked out just fine. Find the number of terms in this sequence. I know this last term, 119, is the first term, 3 plus the number of terms minus 1, which I don't know the number of terms, but I know that the common difference in this case looks to be 4, so multiplying by 4. So 119 is 3 plus 4n minus 4, and so 119 is negative 1 plus 4n, so 120 is 4n, so n would be 30. So there are 30 terms in that sequence. Once again, if I wanted to check that, u sub 30, which we know is 119, would have to equal the first term plus 30 minus 1 is 29 times 4. If we work that out, we get 3 plus, and when we work this out, we get 116. So 119 is equal to 119. So it checks out. There are 30 terms in that sequence. I have a sequence where u sub 6 is 22 and u sub 9 is 31. So find the common difference. How do we do that? We're going to start with u sub 9 and say that is u sub 6 plus, to go from 6 to 9 is 3d's. So 31 is equal to 22 plus 3d. Subtracting 22 from 31, I get 9 is 3d. So d is 3. So my common difference is 3 there. Finding the first term, we'll use u sub 6 to do this. 22 has to equal the first term, which is what we're looking for, plus, if 22 is the sixth term, I need to multiply 5 times d. That's n minus 1 times d, and d was 3. Excuse me, I don't need to put the d in there. I need to put the 3 in there. So 22 is equal to u sub 1 plus 3 times 5 is 15. And so 22 minus 15 looks like it would be 7. So u sub 1 is 7. I want to check that to make sure. So u sub 9, which is 31, would be 7 plus 8 times my common difference of 3. So 31 would be 7 plus 24. 31 equals to 31, so it does check out, and that gives it to me. For your homework tonight, I want you to, or as part of your homework, continued, I want you to read pages 164 through 166. You're going to find this covering the same material I just went over in the video, but it gives you different examples, and if you read over this, it should help you get on through it.